Hi everyone. For this question, it said consider a simple electric circuit with the resistance of 3 ohm and inductance of 2 Henry. If a battery gives a constant voltage of 24 volt and switch is closed when t is equal to 0, the current I in terms of t after t second is given by the differential equation as below, where I in terms of 0 equals to 0, which means that our quantity here is involving time and current, T and I. So when T is 0, I is 0. So for the given dE here, we are going to solve this differential equation until we can get general solution or particular solution for this differential equation. So first of all, we express dI dt as a subject. And then we can notice here, our variable here, our quantity only consists of I only, t we don't have, which means that this differential equation can be solved by separable. So in order to solve the separable, we need to rearrange the term of I to the left hand side and then the term of t remain at right hand side. So for this, we get same the denominator then we move 1 over 24 minus 3i to the left hand side. So when we move it to the left hand side, it will become division. Here remaining 1 over 2 dt. Then in order to solve this, we integrate both sides. So when we have a fraction here, denominator power of 1, so we will integrate using the formula of fraction. Integrate fraction, it will belong to the function. And then don't forget you need to divide by -3, the coefficient of the I here. Then for the right hand side, integrate respect to t, it will be 1 over 2t plus c. Then we simplify until we get I at the left hand side, the rest of it move to the right hand side. So we times -3 to the right hand side. Then we unlock this expression. It will be e to the power of -3 over 2t minus 3c. Then we simplify this, e -3 over 2t multiply with e -3c. So e -3c is a constant. So constant power to the constant, we can denote it as a new constant where it is a. Then we divide it. Move the 24 to the right hand side and divide it by -3. So a divided by -3, constant divided by negative constant, I remain it as constant. So -24 divided by -3 will be +8. Then by given that t is equal to 0, I is equal to 0, we managed to find a is -8. Therefore, our solution I in terms of t will be -8 e power of -3 over 2t plus 8. So this is our particular solution. Then continue for part B. Determine the differences in the amount of current flowing through the circuit from the 4th and the 8th second. Correct the answer to the 3 decimal place. So which means that we want to find T equals to 4, what is your current? And T equals to 8, what's your current? And find their difference. So substitute T equals to 4 into the particular solution that we have just now. Then we evaluate this by using calculator. So it will give us 7.98016. We give more so that later we want to find the difference, then only we correct it to 3 decimal. So we give more decimal first, then we continue with finding the current when T equals to 8. Substitute T into the particular solution. Then we evaluate this by using the calculator. So here we have 7.999, and then 1, 2, 3, 4. We have 4, 9, 5 here. I give more. Then lastly, we find the difference. Then only for this, we round off to 3 decimal place. 197. So when we round off to 3 decimal place, it will be 19. Rounding in will become 20. Then we go for part C. If the current is allowed to flow in the circuit for a very long period of time, estimate the current. So means that T is approximate to infinity. When it's flowing a long period of time, then we have to find out what is the current. So by using the particular solution that we have just now, firstly, we rearrange the power negative back to the denominator so that we can see the approximation more accurate. So power negative move back to denominator. So why we do that? Because we need to calculate for when T approximate to infinity. When T approximate to infinity, 3 over 2T, so it will be approximate to infinity. And when E approximate to the power of infinity, this one will give us infinity. So lastly, for this fraction, negative 8 over infinity will be approximate to 0. So therefore, I will become 0 plus 8. So I will become 8 ampere. Ampere is a unit for current. So that's all for these questions.